Hello everyone, welcome to Unlock Maths. Today we have to discuss signature of a permutation. So first here we will define this. Let's consider if we have given any permutation, alpha belongs to this set Sn, where this set Sn is set of all permutation. Then signature of this alpha is denoted by this Sgn of alpha and is given by this formula. This is product of this alpha of I minus alpha of j upon this I minus j, where this ij, this belongs to this set and value of ij is lies between this 1 and n, right? And here I is strictly less than this j. So signature of alpha is calculated by using this formula. This is the product of this alpha of I minus alpha of j upon I minus j, right? Now we have to note down that this formula we have to use only when any permutation is expressed in two-row form, so that we can find this alpha of I and alpha of j easily. And next here we have to remember that signature of any permutation is always 1 or minus 1. When we find signature by using this formula, we will get signature always this 1 or minus 1. This is because this ij and this alpha of I, alpha of j belongs to this set 1 to n, right? Now here we have to remember that when we have given any permutation in two-row form, we can use this formula for finding its signature, and signature of permutation is always 1 or minus 1 because all these values are belongs to this set, and on simplification we get this 1 or minus 1. Now this will get clear by one simple example. So let's consider one permutation alpha for finding its signature. Let's consider if we have alpha. This is belongs to S4. We have taken this permutation of this set S4, right? Now we know that all this first row, this denotes I, and all these are images of that respective I, right? That means here we can write this is alpha of 1 is here 4, alpha of 2, this is 3, alpha of 3, this 1, and alpha of 4, this is here 2, right? Yes, in this permutation alpha, this 1 maps to 4, 2 maps to 3, 3 maps to 1, 4 maps to 2. So we have write down this is here, right? Now we have to find its signature. Now signature is given by this formula. This is the product of alpha of I minus alpha of j upon this I minus j, right? Where this ij, this belongs to this set having element 1, 2, 3, 4, right? Yes, and this product here over this values of ij here, these are lies between this 1 and 4, right? And I is strictly less than j, right? So we have to put here various values of ij. which are belongs to this set and satisfying this condition, right? That means here we get various pairs of I and j, right? That means here when we have I is equals to 1, j is equals to 2, 3, 4, right? When I is equals to 2, j is equals to, this is 3, 4. When I is equals to 3, j is equals to 4, right? Satisfying this strictly condition, right? And next, if we can write this is I is equals to 4, this j is equals to 4, this is not possible here because we have to satisfy this condition. So this values, this pair is not possible, right? So we get here various values of I, j. So from this first pair we can write when we have I is equals to 1, j is equals to 2, right? We get this first pair. When we have I is equals to 1, j is equals to 3. When we have I is equals to 1, j is equals to 4. So similarly for this one we can make here pair like this one, right? So now we have to put various values of ij here. This is first here we have this is alpha of 1 minus alpha of 2, right? And denominator this is 1 minus 2, right? We have put values of ij, this is here. Next alpha of 1 minus alpha of 3 and denominator this is 1 minus 3. Next here this is product, right? So this is into alpha of 1 minus alpha of 4, right? And this is denominator 1 minus 4. So we have put these values of ij. Next here when I is equals to 2, j is equals to 3, right? So here we have alpha of 2 minus alpha of 3, right? And this denominator 2 minus 3. Next here alpha of 2 minus alpha of this 4, right? And this is denominator 2 minus 4. We have put these values. Now next is this is alpha of 3 minus alpha of 4 upon this 3 minus 4, right? Now here we have put all the values of ij. Now we have to simplify further here by putting all the values of alpha I, right? So for this we have to check this permutation. Alpha, this is here, all first row denote this is I and second row this is alpha of I. That means this is alpha of 1, alpha of 2, alpha of 3 and alpha of 4. So from this we have to put alpha of 1 minus alpha of 2. That means this is 4 minus 3 upon this denominator. This is 1 minus 2. This is as it is, right? Next alpha of 1 minus alpha of 3. So this is 4 minus 1 and denominator 1 minus 3. Next alpha of 1 minus alpha of 4. That means this is 4 minus 2, right? So here we have 4 minus 2 and this denominator this is 1 minus 4. Same for this value here. So we have put all the values of alpha. Now we have to simplify. This is here. Now when we simplify, this is here, we get, yes, all these factor get cancelled. So remaining here we have this is minus sign. Here we have this is 1 2 3 4 5 minus sign we got here. So this is minus 1 raised to 5 and this is minus 1, right? Yes, we have simplified. This is signature of this alpha. This is we got, this is minus 1, right? So in this way we have find signature of given alpha. We got this value is here minus 1. So for this we have to remember this given formula. This is given by, this is product of alpha of I minus alpha of j upon this I minus j, right? Satisfying this condition of ij, right? And we have to use this formula only when we have given permutation in two row form, right? So here we have to remember this formula for finding signature of given permutation, and we have seen how to use this formula for finding signature, right? So yes, that's it for now. See you in the next video. Thank you. Keep watching.